So it's been kind of nasty and I haven't really got a chance to go out and actually film, but I figured it'd start pretty simple with ways to understand and read maps. So from memory, there are three kinds of symbols that you'll find on maps. And the most common one is true north. It looks like this. And then there's magnetic north, which looks like this. And there's also grid north, which looks like this. So true north is basically the true angle between you and the North Pole. The magnetic north is where your magnet points to your magnetic north on your compass before you set your declination, which is a different word I'll get into in a second. And then grid north is a way of finding your direction when the map is laid out like a grid, which doesn't usually, you won't find many maps like that these days. The most common ones are true north. So declination is literally the angle between where you are on the Earth and the difference between magnetic north and true north. So here in Nova Scotia right now, it's 18 degrees from here in Nova Scotia to the North Pole. Magnetic north is offsetting true north by 18 degrees. So if you set your declination on a compass, which is, one second I'll show you, this thing right here. So that's 0 degrees declination. That right out there, and then it goes in 2 degree increments to 20, 40, 60, 80, 90, right? That's your declination, and that's set by that little dial right there. There's a tool that comes on your compass which looks like this thing. Okay, and you stick that in there and you adjust your declination like that by turning it. And that will offset or change the direction, like the diagonal, the declination. Also, quickly to show you with the compass, this is magnetic north right now. Well, this is actually true north. True north is this way because I can turn it this way to put red in bed, and you can look at the mirror to make sure that you're aligned properly, and that's pretty much north right there. So north right now is that way. And you notice it changed because I'm right next to electronics and I'm putting metal right next to it. Another thing, compasses can be really tricky and really sensitive between what affects them and what doesn't. It can be like a power line or an iron deposit in the ground or metal, your jacket, your pocket knife, your whatever. So anything metal can offset it and change it just a little bit. The things that I find really interesting about that is if it does change. Like say for example you're shooting, it's when you take a shot on a compass, it's called shooting. Say for example if you were shooting across a field and you wanted to hit a target or get a reading or an azimuth it's called, or a bearing. There's two types of compasses very quickly. There's an azimuth compass and a bearing compass. Azimuth compasses go 0 to 360 and bearing compasses go 0 to 90, 90 to 0, 0 to 90, 90 to 0. But if you converted it, it would go 0 to 90, 90 to 180, 180 to 270, 270 to 360. So it all works out in the end, and you can convert back and forth. But usually if you're given a set of directions, it's with bearing. So it's, say, north 35 degrees east, which would be 35 degrees, simply. Pretty quickly. So you're taking a shot across a field, and say there's an iron deposit in that field. If you were just shooting just regularly, you wouldn't know that there's an iron deposit there. You wouldn't know that there's that your compass is actually being thrown off by that iron deposit. You would have no way to tell because you're getting a reading, you're still getting a reading, and without taking a back shot, so without shooting at the exact same thing that you were shooting from, when you get to your target, you won't know that there's an iron field there, you won't know that there's different. And anyone following just a set compass shot, they'll still get the same answer. They'll still get the same reading because that iron in that field is still throwing off their compass by the exact same reading. So it can throw off the compass so that your reading is not true, but I find it really interesting that it'll still throw anyone else's compass off by. So it's kind of a, it's interesting to me. But the way that you calculate the true reading is when you take your back shot, say your forward shot will be off by 4 degrees, and that means your back shot will be off by 4 degrees in the opposite direction. So you take the average. There's a math formula that we haven't learned yet, and that's getting really complicated for this first lesson. But you can basically find out what the actual true angle is, what the true azimuth is. So one quickly thing before we finish off this first crazy lesson is maps have scale, and scale is also RF. So if you look at a map and it says this much, say like 1 inch is equal to 500 meters, for example, or one centimeter is equal to 500 meters. We won't make this complicated. So that is a scale. The RF would be 1 to 50,000. Yeah, 1 to 50,000. I had to double check my math on that for a second. But it would be 1 to 50,000 would be the RF. And the scale would be 1 centimeter equals 500 meters. Because an RF is scale without units. And when something is converted to scale, it has to have the same scale. So you could have whatever scale you want. Like 1 banana equals 1,000 bananas, right? Or it could be 1 banana equals 10,000 bananas. It's for banana for scale. But that same rule applies. As long as it's the same unit, it can have whatever. But it's usually centimeters, because maps usually aren't big enough to use feet or meters or what have you. But yeah, really quickly, the grid north, through north, magnetic north, declination, scale, and RF maps. That's really, really way too quick. If you have any trouble understanding this, let me know and I'll slow down to go into more information. But that was our first test run at a lesson, and we'll see how it goes. Thanks for watching.